Hello guys, welcome to my YouTube channel. So in this video, we will learn about an algorithm called as gradient descent. So this is a general gradient descent algorithm, not related with any particular regression or logistic regression or something like that. So you understand this particular section of this particular algorithm so that you can apply this to any of the machine learning algorithms. Okay, so let's start. So with respect to any machine learning algorithm, linear regression or logistic regression or any such type of regression problems, we have something called as cost function associated with it, right? So that is denoted by j theta, right? So here I have denoted it as j theta, whereas theta will have some parameters in it from starting from theta 0 to theta n. So n is our number of features, correct? Number of features that we have. So we'll have so many number of parameters which are to be learned equal to the number of features that we have in our data set. Okay, so that's about thetas and cost function. And whatever cost function that we will be using will be of convex shape. That is, if we plot cost against this particular theta parameters, it will look like a convex shape. So this is called as convex shape. Okay. Now, what our aim here is, in any of the algorithms, our aim will be to minimize the cost or overall loss of any particular regression problem. Okay. So in this case, we have to minimize j theta such that whatever theta values we are dealing with will provide us the cost function at this particular point. So if you just visualize this cost function here in this graph, the minimum point where the cost function is minimum value will be at this particular point, right? So this is the value of theta wherein we have our cost function with minimum cost. Okay, so this is the second step that we have. Now coming to the algorithm of gradient descent, it will have some 3 or 4 steps. So first step will be to initialize the thetas randomly. So how many thetas we'll have will depend on the number of features that we have with our data set. So we will randomly initialize so many thetas with some random number. Okay, so that's our first step. Then at that particular point, we will calculate the cost. But before calculating the cost, we need to pin those thetas, randomly initialized thetas in our hypothesis, and then plug those hypothesis values to our cost function formula to calculate the cost. Once we have the cost, for all the thetas that we have, we will update those thetas using this particular formula here. So you can see for all thetas from j0 to n, theta j is equal to theta j minus alpha into d by d theta j of j theta. There is no need to panic by looking at this equation. This is a simple equation. I will explain it. You will be able to understand it in a clear way. So here alpha stands for learning rate. So you all know from my previous video wherein I have described about the notations, it is called as learning rate. Okay. Now this partial derivative, whatever you are seeing here, this funny notation of d, a bent towards the left side, this is called as partial derivative. Okay, partial derivative. In other words, it is nothing but slope at that particular point. So if we just look at this cost function here, initially let's say we have initialized theta somewhere here. Okay, so with respect to this particular point of theta, the associated cost is this much. Okay, you can see, let's say we get some cost here. Now in order to explain you what this partial derivative does is, so all we are doing here is we are calculating slope of this particular line at this particular point. So that's what this partial derivative deals with. So this is nothing but slope of a line at point theta with respect to j theta. Okay. So initially when we initialize the theta randomly, we will get some cost. At that particular point over the cost function curve, we will find the slope, and depending upon the slope, we will either move towards right or towards left in order to update the theta value. Okay. So let me explain that in a clear way. So if we calculate the slope of this particular curve at this point, the slope will be positive. Okay. At this particular point, the slope will be positive. So once you have the positive slope, if you plug in some value, theta j is equal to theta j minus alpha into some positive value, right? Because this d by d theta of j theta will return as the slope of that particular curve at that particular point. So since we are subtracting some positive value from this particular theta, this theta will be moved towards left side. Okay. So depending upon the slope of the line, the theta will be moved either towards left or towards right. Okay. Why we are moving towards left or right? Because we have to reach at this particular point wherein the cost is minimum. Okay. So at this particular point, I am saying that cost is minimum. Other thing to notice here is d by d theta of j theta is 0, right? Slope at this particular point is 0. So whenever the slope at any particular point gives us the 0 value, then we can be sure that we have reached at the minimum cost of that particular cost function. Okay. So this is how one example, this is how we can understand gradient descent with one example. Let's say we have initialized theta at somewhere here initially. Okay. So now we will get cost at somewhere this particular point. Okay. So the slope of the line at this particular point will be negative. So it will give us the negative slope. Okay. So since we have negative slope, in the equation theta j is equal to theta j minus alpha into some negative value. Correct. Since we are multiplying negative with negative, we will end up adding some value to this particular theta, right? Add some value. Since we are adding some value to this particular theta, now this will move towards right side. So either you initialize the theta, whether it goes towards this particular direction or in this particular direction in the first step. Eventually, because you are calculating the slope of a particular curve at that particular time, at that particular point of the theta, we will always end up moving in the right direction. Okay. So we will reach towards our required minimum cost function goal. So this is how gradient descent works. There is another thing called as alpha here, right? I told you this is called as learning rate. So what happens if this learning rate is too large? If we give some large value to learning rate, let's say while updating this thetas, if we are multiplying with some large value with some positive slope, we may at the first step reach at this particular point. Okay. But during the next iteration, we may overshoot the minimum here. And then again, we may come at this point and then come at this point. We can wander like this, right? So we may never reach our global minimum point, which is our main goal. So this should not be too large. Okay. So what happens if learning rate is too small? So let's say we are starting at this particular point. If learning rate is too small, the movement from this particular point to the global minimum will take forever. So if it is very small, we end up taking very small baby steps, right? So at each iteration, we will end up moving only so much so that we will not see any difference between the cost function, that much difference in the cost function between the iterations. Okay. So that's why it is very important to have the learning rate set to some proper value so that it is not too large or it is not too small. So this is about learning rate. This is very important. Okay. Now, if you guys have understood this much, the gradient descent algorithm is done. But for your sake of understanding, I have broken down the steps further in this gradient descent. So initially what we are doing, we are anyway initializing the thetas to some random values. Once we initialize the thetas, we need to compute the hypothesis, right? We will compute the hypothesis. H theta of x, it can be anything. In case of linear regression, it is theta 0 x0 plus theta 1 x1. So it can be anything. This is just an example of univariate linear regression. But we can have any of our hypotheses available with us. So after initializing thetas with random values, we will compute the hypothesis. Once we calculate the hypothesis, we plug in these hypothesis values, also called as predicted values, in our cost function to calculate the overall cost. Once we have the cost, we will apply this formula of gradient descent to update the thetas respectively. So how thetas gets updated, I have explained it as part of this figure here. Okay. So once we have this particular step for one iteration, what we can do next, we have to repeat it multiple times. Why we have to repeat it multiple times? Because since we are taking small steps towards our goal, which is to reach the global minimum, we have to compute hypothesis, calculate the cost, update the thetas multiple times until we reach the global minimum, wherein we get the slope of this particular cost function at this point as 0. Okay, so this is about gradient descent. So in order for you to repeat the steps, you have to repeat step number 2, step number 3, step number 4. You have to repeat multiple times. Repeat multiple times. How many times? We never know exactly at any point of time how many times we need to repeat. So it's suggested to try with 100 iterations, 200 iterations. You can even go up to 1000 iterations to find the optimum values for thetas. So once you have the updated values for thetas, wherein you will find the cost is not going down further, at that particular point you can stop your gradient descent algorithm and take the last updated value of thetas. Okay, those thetas you can make use in your hypothesis in order to calculate your or predict your next upcoming values. So in case of linear regression, h theta of x is given by theta 0 x0 plus theta 1 x1, right? So this is univariate linear regression. Now after gradient descent, you would have some values for thetas, which will be definitely different from the initial random initialization. After gradient descent algorithm, you will have some other set of values which you can make use of in this particular hypothesis to calculate or predict for any new value or new data set that you have never seen. Okay, so that's it about the gradient descent algorithm. If you guys have any questions on this, please reach out to me in my comment sections. Till then, happy learning. Bye.